Okay, I'm going to go through the solutions for these two inequalities. So let's look at our first one. We have 2x minus y is less than negative 2. So our first step is we have to get y all by itself. So what I can do is I'm going to start writing it up here. 2x minus y is less than negative 2. I'm going to subtract 2x from both sides. So I'm going to have negative y is less than negative 2x minus 2. I'm going to multiply both sides of this inequality by negative 1 because we want a positive coefficient in front of the y. So I get negative 1 times negative y is positive y, but then I have to flip the sign, and then I get 2x plus 2. So that gave me my y-intercept there, and there's my slope. So I'm going to plot this point. My y-intercept is at the 2. My slope is 2. So it means I go rise over run up 2 over 1. And I can put another point there. So this is greater than, but not equal to, so that means I have a dashed line. So I'm going to put a few more points on there. Okay. And if y is greater than, it's these values here. Okay, so let's do our second inequality because we're looking for solutions in these systems. I have x minus 2y is greater than or equal to 2. I'm going to subtract x from both sides. So I get negative 2y is greater than or equal to negative x plus 2. I'm going to now multiply both sides by negative 1. So I have 2y less than or equal to x minus 2. I'm going to divide both sides by 2 because I want to isolate the y. Those reduce and I get y, I'm going to write it over here, is less than or equal to 1/2 x minus 1. Okay. Alright, so hopefully this will work out. So now I have 1/2 x minus 1, so negative 1 is my slope-intercept. And then my slope is 1/2. It's positive, so up 1 over 2, down 1 over 2, down 1 over 2, and so on. And it's less than or equal to, so it means it's a solid line. And I need to highlight this area. That is where the two meet. So hopefully I did not mess that one up. Looks good to me. Okay, so let's move on then to our next slide. Okay, and I'm going to go back into drawing mode. I have 3x plus y is greater than negative 2. So first thing I have to do is I have to isolate the y. So 3x plus y is greater than negative 2. So I got to get the 3x off of both sides. So I get y is greater than negative 3x minus 2. So I'm all set to go ahead and graph. I've got my y-intercept right there, and I've got my slope right there. So my y-intercept is negative 2. My slope is negative 3. So down 3, 1, 2, 3 over 1, or you can go backwards 1 and up 3. 1, 2, 3, and it's greater than but not equal to, so I'm just going to make this a dotted line. Sorry, it's pretty ugly. Okay, and then I'm going to shade everything above it because it's greater than. The y values are greater than that. Okay, so let's make our next one. So our next equation was x minus y is less than negative 2. So I'm going to subtract x from both sides. So I get negative y is less than negative x minus 2. I'm going to multiply both sides by negative 1. So y, flip the sign, is greater than x plus 2. Okay, so now I have my y-intercept and I have my slope. So I'm going to put my y-intercept there, and my slope is 1. And again, this is going to be a dashed line because it's greater than but not equal to. And let me go ahead and I'm going to do my shading, so it's all the stuff above that. And our solution set is where those two meet. Okay, and finally number 8. Okay, so let's look at our first inequality. X plus y is less than -1. So I'm going to subtract an x from both sides. So first thing I have to do is isolate the y. Y is less than -x minus 1. I'm all set now. I've got my intercept and I have my slope is -1. Both of them are -1. So I'm going to plot my intercept here. And my slope is -1, so it's going to slant down. And remember that since it's less than but not equal to, it does not include the actual line itself. So it's a dashed line. And it's less than, so it's these values below. Okay, it's all those values below. So now, let's go ahead and plot our second one, which is pretty simple to do. Y is less than or equal to -2. So it doesn't matter what x is, y is going to be all those values below -2. And since it's less than or equal to, it's a solid line. So I'm going to go ahead and shade. Okay, and my solution is where the two meet. Okay, hopefully this made sense to you and you're able to check your answers.